In this part of the video, I'm going to discuss the network partition tolerance of Riak cluster. So at first, I need to set up a Riak cluster with 3 nodes. So all these 3 nodes are running on the AWS Riak node 1, 2, 3. And since all these 3 nodes are in the private subnet, I also need a jump box to allow the external access to these 3 nodes directly. And for each of the Riak node, I open the 22 port for the SSH purpose, and the 8087 and the 8089 ports for the React API itself. So now let's check the current status of our Riak cluster. So it shows the ring is ready and all 3 nodes are available. The status is up. So our experiment or the test start from to store some new object into a test bucket. And since we'll focus on the behavior during the network partition, so it's important to make sure our configurations for that bucket is correct. So let's check the property of current text test bucket. So there are 2 very important settings for this experiment. One is the allow multiples. So allow multiple allow the React resolve the conflict internally, so it will only return one object to the client even there is a conflict record inside the database. And also the last right wings settings. So the default last right wing setting is false, which is allow the Riak to use the vector stamp, but you could consider the network partition will allow the concurrent write to the database. So there's no context we could use to resolve the conflict using the vector clock. That's why we allow the React just using a temp step. So set the last right wings equals to true. Now, so settings correct, and we want to just store a new object into any of the node in the cluster. And we got this 200 response, and if we try to fetch it from the other node, and we got the same result. So the write is propagated from one node to the other node, but it will take some time. So that's why Riak is a AP database, but it allows the eventual consistency. And now, let's see if we try to simulate a network partition to make one node disconnect from the other 2. So now the cluster become 2 parts. One part is we have the picture to show that. So now, under normal conditions, we have 3 nodes, and during the partition, we have 2 nodes on one side of the cluster and 1 node on the other side. And if we try to make a new write into the different component of the clusters, and we will see during the healing, and eventually all the write will propagate to the other nodes, which is not the original node writing nodes. And we will also study like what if concurrent write happens, and is there any potential data loss in the Riak cluster? Okay, so I'm using the IP table tools to disconnect that node from the other two. So let's see, simulate. But if we want to check the current status, it will take a while to show all other two nodes are down. So now it's only one down. It will take a while, and we will revisit that later, even in the other part of the cluster. So right now the status is not updated yet. So let's try to write a new object into the partition only have one node up, so 117 node. And we write a new object about the shipping address. Take some while. And write the other new object, the zip code, into node 1 and 2. Okay, we got 200 response. Here, I don't know why, but let's see. Okay, now if you check the node 3, the status, and the other two nodes are down, since they cannot communicate with the other two nodes. And if I check from the other two nodes, and the node 3 is down. So now we have the network partition. And let's see if we could fetch the address here. Maybe that write is not. Okay, the write is successful, but I don't know why it's stuck there. Okay. And here is we launch the new write into the different part of the partition. And here we want to trigger another concurrent write. We just update the order status. So in current node 1 and 2 and node 3, they all have the order status like preparing, I think it's not preparing for shipping, is processing the order. Yeah, and now I want to update this order status through the node 1 and 2 to change the status as cancel. And now the status in 1 and 2 are canceled. And I want change the status in node 3 to shipped. Okay, so now status in node 3 is shipped. So now we introduce a conflict record for the auto status in the Riak cluster. And we will recover the partition and see what happened. So to recover the partition, we just restart our IP table. And it will take a while to show so although it said the Riak cluster is all up, it will also stay a while to do this one. Oh, it's working. So now you could say, like, if we try to fetch the list of the keys from the node 3, you could only get the zip code and the order status. But it's interesting, like, we also put another object into that. It's a shipping address, right? We just fetch that before from the node 3, but now it's not in the list. And if we try to do this, still we only have the order status and zip code, so we're still missing the address. It will take a while, so just let's wait it and just see what's the current order status. So the current order status is shipped. Now let's see. So it's shipped. Although I query this object from the other node, the node 3. So, but if you remember, like we setting the order status as cancelled in the node 1 and 2 before. However, since we setting the bucket as just don't allow the multiples and last write wings, and the order status is shipped has the latest time step, so it will overwrite the orders that it's not overwrite, it will just win once the Riak try to resolve the conflict for ourselves. And now I think maybe it's okay to check if we have the complete list of the, oh, still not there. Okay, now you could find it. So if you access one node and you have the completely list of the keys, we in node 1 and 2, the address object actually is not writing into this 2, it's writing to node 3, but it's merged into the node 1 and 2 during the partition healing. And if we want to query the address from these 2, they give return us the shipping address. And so in this experiment, it told us the last write wins in Riak is not a safe and useful strategy for the record is mutable. And so if you will update the object frequently, and you have the risk of your of the network partition, which is always happen, it's better to allow the Riak to return the multiple conflict record to the client and ask the client API to decide which record should keep, and also just have the trace of all the writings to the Riak cluster, instead of just ask the Riak to drop the ones they think that is not a valid write, and they will just makes the client cannot trace back.